feet. Now the average velocity is going to be that divided by the time. The magnitude of the average velocity is 24.42 divided by 22 seconds. So 1 point something. So much smaller. Remember again what all of these things mean. If someone else, instead of going all around, if someone just goes this way, straight down, they would only have to go at 1.11 feet per second in order to catch up to you. You know, the particle would be going all around. The particle's speed is 2.99 meter. I should change that, right? Feet per second. The particle speed is 2.99 feet per second. So the particle is going around at 2.99, but this guy would only have to go at 1.11, much slower. Okay, how about the angle? Remember, whenever you describe a vector, you need two pieces of info. So if I describe the magnitude of the average V, or the magnitude of the average of the D, I also need its direction. So the direction is this angle. See this angle here? You see if I draw like a XY axis here, this is the angle that I need. I need to be able to express the angle of the vector D with respect to the x-axis. So how would we get that? Actually, it's going to be pretty simple. Look what I'm going to do. I'm going to argue that this is an isosceles triangle. In this problem, some good geometry comes in. This is isosceles triangle. So if this is 109, this thing is two angles are the same. So that's going to be 109 subtracted from 180 is 71. Divide that by 2. 35 and a half. But now add that 35 and a half. You see over here, 35 and a half. Add that 35 and a half to this little angle. Well, if this is 34, this is also 34. 34 plus 35 and a half. Okay? So this thing, 34 plus 35 and a half, 69 and a half. So the official, this is the answer then. The magnitude of the velocity vector is 1.11 feet per second. Its direction is what? What is that? This one is 69 and a half. You want to express this one? Add 180 to that. 180 plus 69 and a half, 249 and a half. That's the answer. The velocity vector is 249 and a half degrees. And this is its magnitude. Magnitude and direction. Two pieces of info. So it's basically telling you if this particle goes this way, another person can be walking at 1.11 feet per second and headed at 249 and a half degrees. And they'll catch up to the other guy. Okay? Now, let's do the average acceleration and the instantaneous acceleration. The average acceleration is V final minus V initial divided by t, right? So let's go over here. This one, we're going to have to do it with the vector method. There isn't a quick, like a law of cosines or anything like that. We're going to have to take the V final, break it up into its components. Take the V initial, break it up into its components. Now, what's the magnitude of V final? Its magnitude. And the magnitude of V initial. I'm going to assume that in this problem, that the particle maintains a constant speed. Assume it maintains a constant speed. It doesn't change. In that case, the magnitude of V initial is equal to 2.99. It's the same speed that it's going at. And the magnitude of V final is also 2.99. Okay? So assume that the particle is going at a constant speed. And now, break down each one into its components. How do we break the V final into its components? Well, we need this angle, right? Down here. We need this angle in order to break the V final into its components. What is that little angle down there? Again, this problem is going to have some geometry here. If this is 285, this little piece is what? 15 degrees. Well, don't confuse with the 15 feet here. This little piece is 15 degrees. And I believe this is also going to be 15. Because the velocity vector is tangential to the circle. If that's 15, this one can also be argued that it's 15. Because if this is 15, this is, you can make a, let's see here, a triangle like this, and then argue that this is 15. If that's 15, this is 90 minus 15. If that's 90 minus 15, that's 15. Or you could do it just a visual way. Just look at it. Does this look 15? Okay, 15. Does this look 15? Yeah, they look the same. Okay? No. Okay, so break this down. V final, therefore, is equal to 2.99 cosine 15 I hat plus 2.99 sine 15 j hat minus V initial. Okay, so now V initial is what? We need this angle here. We need this angle. So now we got here a 34. This is 34. This is, let's see here. Let's write it here. If this is 34, and then this is like this is V initial, right? If this is 34, this is also 34. And then this is a 90-degree angle because the velocity vector is tangential to the circle. So this is 90 minus 34, which makes it 56. Right? And then this would be 124. There you go. Okay, so some good geometry. So now break that into its components. 2.99 cosine of 124 I hat plus 2.99 sine of 124 j hat divided by t, which is 22 seconds. Now, of course, you can't combine the I and the j. So you can combine this and that. So you're going to have 2.99. You can factor that out. Cos 15 minus cos 124 divided by 22 I hat minus 2.99 divided by 22 sine of 15 minus sine of 124 j hat. Now you might be saying, okay, well, what if I go through this? I still don't know if I got the right answer. I'm going to then show you how to check your answer. After all this stuff that you don't know, you mean you're clueless. Am I right? Am I right? So let's calculate this. Look at what we're going to do. Cosine of 15 minus 0.207 okay, and then the y component oh, you know what? Sorry, this one should be plus sign. This is minus, this one is plus. This is minus. So this one should be plus here. Okay, the average acceleration vector is 0.2